In this video we're going to be discussing perimeter and area on the coordinate plane, but before we do that, let's just get quick definitions of what perimeter and area are. Okay, so perimeter is the sum of the lengths of the sides of a polygon, which means we're going to add up the edges around the outside, and that would be the perimeter. Okay? Area is the measure of the number of 1 unit squares that will fit on the inside of a polygon. So this is the measure of the outside of the polygon and the inside of the polygon, right? And so this word polygon is showing up for the first time. And so what that generally represents, okay, my pen is messing up. What that generally represents is any shape that has straight edges and is closed. So things like these are polygons, okay? It can be as simple as a triangle, right? It could be a square, rectangle. So any of these shapes are polygons. So when you see that word, we're just talking about straight sides, and we are talking about enclosed figures, right? So generally speaking, this is the stuff that we're going to be finding the perimeter and area of, okay? So I'm going to put these formulas up. I will let you pause the video and write them down as you need to. I'm not going to go into great detail about them. I think they're all things that you should have seen prior to coming in here. And so what we're going to do is we're going to jump to the next one, which is talking about the perimeter and area of these different shapes. So for the first one, this is a rectangle, okay? And so what we're going to do is we're going to just, for the perimeter, you could use the formula which says 2L plus 2H, okay? Or you could just add up the sides. Knowing it's a rectangle, we can say this is 10 and this is also 7. And so the perimeter would be add up all the sides, which you could say is 10 and 10 is 20, and 7 and 7 is 14. So it's really 20 plus 14, which is 34. Okay? The area for rectangles just says multiply the length times the width. So the length and the width are the 7 and the 10. So I'm going to say 7 times 10 is equal to 70. And here's why I just wrote this inches. Perimeter is always measured in the same units as your dimensions, so in this case inches. Area is represented in square inches because, again, our definition said it is the number of 1 unit squares, right? So we're going to use square inches for something like that, okay? So I'm going to skip the triangle for a second because it's a little bit different, and we have to make sure that we spend enough time on that one. So let's just quickly do the circle. The nice thing with circles is they give you formulas, and you can just plug into the formulas, and just remember that the C here represents circumference, and circumference is another name for the perimeter of a circle. Okay? So the circumference of the circle, or the perimeter of the circle, the formula there says, if we use the formula 2 pi r, and I know that this is a radius because it starts in the center of the circle and travels to an edge, okay? In order for it to be a diameter, it would need to go all the way through to the other side, which ours does not. Right? So we're going to use the 2 pi r formula because we know a radius. So I'm going to plug in 2 times pi times 4, okay? Looks like 8 times pi, right? And so let's get a good estimate for 8 times pi. I'm going to pull out my calculator, and 8 times about 3.14 represents about 25.2. So we're going to say a good estimate for this, for the outside edge, is about 25.12 feet if we were to travel or around the outside edge of this. Okay, to represent the area of this shape, hey, we had another similar formula that said pi times the radius squared. So for this circle, we're going to say pi times 4 squared, which is 16. And so again, we're going to let the calculator do that one. So I'm going to hit 16, and this time I'm just going to use the pi button on my calculator. It'll be a little bit more exact, and I get something about 50.3. Right? So I would say that the area of this circle is about 50.3 square feet, which we use this little squared symbol for. Okay? So our last problem is a little trickier because if you look at the triangle formula, it says in order to find the perimeter, you need to add up all 3 outside edges, and in order to find the area, you need to know a base and a height. Right? So if you take a look at our problem, I'm missing this whole bottom side, which is actually the base. So I'm missing the base, so I can't find the area easily, and I also don't have the base to use for the area. So our first task here is find this missing information. What is the base? Okay? So in order to do this, what we're going to focus on are the little triangles that we created. So if you notice this one right here, okay, is a right triangle. And we know how to find the sides of missing triangles, and that would be using the Pythagorean theorem. So you probably should have used that before. I'm going to go through the process one time, and then I'm not going to do it for the other side. Okay, so I'm going to do this other one. If you notice, there's another triangle here. Okay, this other little one. So this is the one I'm going to focus on. that one. Excuse my not straight line. Okay, and so we're going to focus and find the area, the missing side of this purple triangle. So I'm going to say this I don't know. So I'm going to say x squared plus 4 squared, because this is the other side, okay? The other leg is equal to 10 squared. Okay, and so this means x squared plus 16 is equal to 100. Right, and then x squared is equal to, that looks like 84. Okay, and when I square root 84, I'm going to say I get about 9.2. Right, so I'm estimating that it's about 9.2. It might be a little bit smaller or larger than that. So what I'm going to do is I'm going to get rid of this, and I know that that little piece here from the corner to this height line is 9.2. Okay. You can do the exact same thing with this right-hand yellow triangle, and I'm not going to do all that work, but you would find out, I'm going to get rid of all this, okay, that little piece from the height line to the right-hand side is worth exactly 3 units. Okay. So it looks like my base now, after I did the Pythagorean theorem, is worth 12.2 total. So I'm actually going to get rid of this entirely, right, and I'm going to say that this whole bottom edge is 9.2 plus 3. Okay, 9.2 plus 3 is 12.2. So I'm going to say this whole thing represents 12.2. Now I can find the perimeter. So for the sake of space, I'm going to get rid of all my Pythagorean theorem work. And we're going to say now the perimeter for this shape is 10 plus 5 plus 12.2. All right, 10 plus 5 plus 12.2 looks like 15 plus 12, which is 27.2 centimeters. Okay, so that took a little bit more work because I needed to find a missing edge, and I could do the same thing with area. So I'm just going to say the area is 1/2. My base is 12.2, okay, and my height is 4. Okay, and so if you do this and multiply this out, you get about 24.4. So I'm going to say 24.4 centimeters squared. Okay, and that would be the area of this triangle. Okay, so you can see that sometimes we're going to have to do a little bit more work if it's not given to us. Do what we know about these shapes, right, and find the outside edge that we need. Okay, so we're going to skip this, and we're going to move on to the area addition postulate. And so what the area addition postulate says is that if you have a shape that is not standard, right? So again, if I were to pull out some of my standard shapes here, if your shape looks like a rectangle, we have a formula for that. If it looks like a triangle, okay, we have a formula for that. If it looks like a circle, we have a formula for that. But if it looks like something like this, we don't have a formula for things that look like that. And so what this postulate is saying is that if you can break up a strange looking shape, we call these a lot of times irregular figures, if you can break this up into some of these standard shapes, and you take the sum of the areas of those, that we can use that to find the area of these shapes. So what I'm going to do is I'm going to look at this and say, okay, I see a lot of congruent dashes. So let me mark those on the picture just to get a better visual. Anything with 1 dash is worth 3. So this is 3, all the way down the steps here. And this bottom one has double dashes. That's the 9, which has double dashes, so this is 9. So what I'm going to do is I'm going to just draw a couple lines in here. And if I were to draw this line, okay, and I were to draw this line, I just took this irregular shape and I broke it up into 3 triangles, or in this case 3 rectangles, and in this case this one's actually a square. So I'm going to say this is 9 by 3. 9 times 3 means that this one's worth 27. Okay, this one is, we don't know, by 3, right? We know the top is 3, but we don't know what the bottom's worth. And here's what we do know. This little piece here is worth 3, so that would be kind of like this piece of the 9, which means if this is 3, that means the rest of this, okay, all the way down to the bottom, is worth 6, and so that means that this is 6, right? Thinking about this little rectangle here. So this is 6 by 3, which is 18, and then we could do the same thing. Actually, we don't need to because there's a little 3 over here, right? So we can say this is 3 by 3, which is 9. So I just found out that if I break up this irregular shape into rectangles, that I have areas for those rectangles of 27, 18, and 9. And if I add these together, I get 54 centimeters squared as the area of my irregular shape, right? So you're going to come across shapes and you're like, I don't know how to find the area of that. There's no formula for it. It was not given to me. Break it up into shapes that you understand, right? And you'll be able to use that. Okay. So one more problem. Let me make sure. Yep, one more problem, okay, and we will be done. So just kind of preview what we're going to see next. This is on a coordinate plane now, right? And they're just giving us the shape of this rectangle on the coordinate plane, and they're asking us to find the area and the perimeter. And so we're going to do the same things, except we need to remember that straight edges, horizontal and vertical edges on a coordinate plane, we can just count boxes to find out how long the line is. So I can say in this case, this is 1, 2, 3, 4, 5, 6, 7, 8 units long. And then I can do the same thing here, and if you do that, you'll find out that this is 6 units long. So I found 2 of the edges. If I'm doing perimeter, I need to know what this third edge is, though. Okay? And so we had the distance formula, right? And so the distance formula will help us to find the area of that. So I'm going to use the distance formula and say the distance is equal to, it said subtract the x values, which is 3 and negative 3. Alright, so 3 minus negative 3 squared plus, now let's subtract the y's, 6 minus negative 2, 6 minus negative 2 squared. So if I were to simplify this, this looks like 6, right? 3 minus negative 3 is positive 6 squared, which is 36. And this is 6 minus negative 2, which is 8. And 8 squared is 64. So if I add together 36 and 64 into the radical, I get 100, and that makes this actually 10 exact units long. So now if I were to ask you to find the perimeter of this shape, it's really just 6 plus 8 plus 10, which is 24 units long. Okay? And then the area, because this is a rectangle, is 1/2 base height. And so to find the base and the height of this, remember base and height are always at a right angle, and if you notice I have a nice right angle here. So I'm going to say that the area for this one is 1/2, okay, the base of 6, and the height going up and down of 8. And in this case, coincidentally, it also comes out to be 24 square units. But remember, don't think that that's always going to happen. This is just a coincidence with my problem. Okay, so on a coordinate plane, we're just going to apply what we know about measuring distances on the coordinate plane to help us find any of the sides that we don't have, right, in order to solve the problem.